Hey coders out there, Stefan here from Be a Python Dev, about to do this reverse integer Leetcode problem. It's in the easy category. It's under the problems or the Explorer section. I'll show you Explorer. We've been doing this for a couple days now. Top interview questions in the easy collection. It's good to work through to get comfortable with the Leetcode platform and kind of what's going on here and just remembering base algorithms. So for this one, given a 32-bit signed integer, reverse digits of an integer. So if we're given 1, 2, 3, the output's 3, 2, 1. Negative 123, negative 321. So we gotta watch out for the negative values, and if the input is 1, 2, 0, the output would be 21. That's because the leading zero gets dropped, because why would you want a leading zero? It doesn't make any sense. Assume we are dealing with an environment which can only store integers within the 32-bit signed integer range, negative 2 to the 31 and 2 to the 31 minus 1. So for the purpose of this problem, assume that your function returns 0 when the reverse integer overflows. So that's kind of a tricky part of this that we're going to have to account for as well, is being able to check the overflow value. We're going to do this specifically or strictly in the realm of integers and numbers. So to do that, we can use module operators and divisions, I believe. It's been a while since I've done this kind of problem, so bear with me. We might have to run through it a couple times. The reverse is x. We're going to need isneg equals x is less than 0. So this will check the condition. If x is less than 0, it's a negative number. If is neg x. Can I do times equals? I'm pretty sure I can do times equals -1. So this will turn it into a positive number. So we're only dealing with positive numbers. It makes our math a little easier. Actually, I don't think that matters, because if you just do divide by 10 and you take the remainders, it would be all the same anyways. I think we might need to do this for our overflow check because of the way signed and unsigned integers are handled in computer science. We may or may not actually need this. We'll just go ahead and develop this and see where we end up going. We want to have an answer value. So our answer value will just be 0 for now. Is that where we care about negative numbers? Because I think at the very end, you would end up with like 10 divided by -5, and is that a negative remainder or a positive remainder? Yeah, anyways, that might end up impacting the negative, the final answer. Either way, it's just best to just work with all positive integers. Maybe I'm saying things out of my butt. Comment below if I am, if negative numbers don't matter or not. We'll just assume they do because this is what we're started. Sorry for going on a tangent. So what do we want to do? So if x is 0, we just return. I don't know if we need to do that specifically. Do we care? What if it's a single digit? Do we care about that either? I guess we need to do this while x is greater than 10. Does that make sense? While x is greater than 10, yeah. Yeah, I'm pretty sure we can just do this in place too. Or do we just do while x is greater than 0? I think we just do while x is greater than 0. Yeah, I think you need to. Anyways, we do ants times equals 10. So for the first case, this won't actually do anything. And then we do x modulo. I think it's just 1. Oh man, I'm so rusty with math operations, I apologize. This is how you can tell I'm doing it live and not just looking at the other screen at an answer or something as I stumble through this with y'all. Anyways, x modulo 10, no, I think we can just do x equals, no, modulo, nope, that doesn't work anyways either, because we're not doing it on itself. equals, oh my gosh. I think you can do ants plus equals x mod 10. I think this does work. And then I think you want to do floor division. I don't know if you can do this. This may work. This is kind of a neat little trial experiment that we're going to do. So let's just print the answer here. We're not going to worry about the checks right away. And what is our test case we're looking at? 1, 2, 3. Let's see if this actually runs, because I don't know if you can do floor division equals in an assignment. And we actually need to return this answer. That was silly of me. Okay, 1, 2, 3, your answer equals 3, 2, 1. I'm actually surprised that that worked. So now that should be everything we need to do. This will make it equal to 0 if we're looking at a single digit, like 5. If our input is 0, we won't even hit this, and then we'll just return 0. So that covers that case. We do want to check the overflows, and the overflow is kind of interesting. Unless you actually know what 2 to the 31st is off the top of your head, you can use the Python bit shift operator. So I actually pulled up another screen to kind of talk about that. So my face just turned really blue all of a sudden. Thank you, Python screen, and my amazing lighting I have for this. So this is a bit shift, and this will just operate on just like a one bit. So if you have 1 in the first value of 0, actually, this is just 1, right? Enter division or module by 0. Oh, it's this. This is the bit shift. So, okay, so this would equal, in binary, this would equal something like this. So I think this also works too. No, this is a byte string. I forgot how to convert a byte string to an integer. Anyways, let's keep talking about this. So if we did this operator, this would be equal to 0, 0, 1, 0, or 2. And then similarly, kind of, if we move it all the way over 3 values, which would equal 1, 0, 0, there should be 8. So 8. So we can take advantage of this bit shift operator to do our overflow check. So if ants is greater than 1, I think we're okay with this. To the 31st, return 0. So this should check the overflow case, per se, I hope. If is neg, return 0 minus. You can also do ants times equals 1, or times equals -1, or you can do return 0 minus ants. This will also turn it negative. And then if it doesn't meet any of these cases, we assume we're good to just return the positive value. So let's do this for a negative number just to check. All right, so it appended our negative correctly and it flipped it correctly. I'm gonna go ahead and submit this, though I kind of will be surprised if we're actually checking the overflow correct. This may be like an off by 1 kind of problem where I might need to move this to 1 to the 32nd. But I believe this is the generic case. Okay, that actually did work for the generic case of checking our overflow. So utilizing the bit shift operator to get us a very large number that is equal to 2 to the power of 31 minus 1. And then since we are operating in the positive number space, we don't actually need to do this check because it's handled for us in the positive signed integer range check. So that's kind of why we're covered there. And let's check our distributions here. Runtime beats 64% of the Python 3 submissions. I'm pretty sure a lot of these higher or shorter ones, they might be converting into strings. That's kind of cheating. You can also maybe like convert it into a list and then flip the list using the built-in reverse function. It's also cheating. Don't do that. Absolute value. I don't think you need to use the abs function, but I'm kind of surprised that this is a faster solution. It's only faster by like not even 12 milliseconds. For exit range, I'm surprised they're also looking at the length of the numbers. So is he converting it into a list here? Okay, so there's the bit shift that I was talking about. Actually, he's not doing a bit shift, he's just doing the exponential value. So that works as well too. A little easier, I guess, if you just raise it to the power using the exponential. But it's sometimes fun to learn new stuff. So we learned bit shifting. So that's also cool. Return x equals blah, 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 blah. Yeah, I'm still surprised they're doing this. A little more complicated in my opinion. Let's see what one of these slow guys is doing. While a is not equal to 0, num times 10 plus a modulo 10. So they're doing this in the same thing. They're casting this to an integer, even though it's already an integer. That's weird. I guess you could have just done the floor division to force it to be an integer. I'm not sure why you needed to do this and why this is so much slower. Using a double conditional. Is this a little slower? Okay. Our memory distribution is not too good. What are the faster boys doing here? Wow, he just actually used the actual value. That's surprising. Okay, so this is kind of what I was talking about, where you cast it to a string and then you just reverse the string. So it's cheaty, and it's also a lot more memory efficient. Cheaters. What else can be done? This looks like a kind of normalized peak for people that are doing the numbers. No, this is strings. This is the reversing the strings. So all of these people here are cheating. Is that true? String negative negative 1. Cheaters. You're all cheaters. Yeah, so I hope you guys like learning how to deal with the numbers on this and work with inflating the answer and then taking the modulo and then appending that to the answer. So the modulo is just the remainder if you're not familiar with that. So that lets us keep everything in the number space and be a little more consistent instead of casting to strings, and that might be a little more complicated, or there might be some kind of limitations in a system, like maybe you're on a low power embedded system and you don't really have access to strings. I don't know why you don't have access to strings, but there might be some kind of limitation. So definitely be aware of that. Try to challenge yourself to learn new things when you can. So, all right, if you like this content, smash that like button down there at the bottom and give us a subscribe. It definitely helps me push out more of these videos. Take care. Bye.